There it is. Very good. Okay, continuity today. There's lots of kind of formal definitions of continuity. The easiest way to think of something being continuous to me is if you can draw the graph without picking up your pencil. So if you can draw the whole graph without picking up your pencil, then we're looking at a graph that is continuous. Okay, so 4 different really types of continuous and continuity. When we talk about this, I'm going to draw a picture of each one for you. And the first one that I'm going to draw is just kind of a little polynomial. Just make it look a little bit like that. So any kind of polynomial that, again, I drew that whole graph without picking up my pencil means that this graph is continuous. I'm going to call this graph f of x so that I have something to talk about there. And I'm going to say that this graph f of x is continuous for all values of x. Okay, so any x value that you choose, if you choose an x value of 1 or 3 or 100 or negative 100, any value of x, this graph would be continuous. And again, a good way to think of that is if you can draw it without picking up your pencil, that whole graph is going to be continuous. All right. Our next type is going to be when we have a hole in the graph. Okay, when we see a graph that has a hole in it, I would have to pick up my pencil to draw the graph and jump over the hole. So this is our first type of discontinuous graph or discontinuity. Let me draw a little picture of what that looks like. So maybe something a little bit like this. And I'm going to say that that hole right there is happening at an x value of a. So I'm going to call that x value a right there. It could be like negative 2 or something like that if you wanted to assign a number to it. I'm going to call this graph g of x, again, just so that I can talk about it. And I'm going to say that g of x is discontinuous, and this is what we call point discontinuity. So anytime that you see a hole in a graph, it's what we call point discontinuity. And I'm going to start abbreviating that word discontinuity, just D-I-S-C, disc. So you'll see me start writing the word disc on there. So g of x has point discontinuity where x is equal to a. So let's say again that was at like negative 2 if you see that number on there. Very good. Okay, so our first type of discontinuity is what we call point discontinuity. You may also see this when you have a hole in your graph. It may also have like a little point right up here. That is still what we call point discontinuity. Okay, so even though it's got a little function value up there, it doesn't have it inside where that hole is. So we're still going to call that point discontinuity. All right, our third type of discontinuity is going to be where we have a vertical asymptote. And we have a vertical asymptote. So let me draw an asymptote on here. I'm just going to make my vertical asymptote kind of right there. And I'm going to draw a horizontal asymptote right here. And it doesn't really matter where the lines are. I'm going to draw mine like here and here. Okay, so it could be in the opposite corners. They could both be going down towards negative infinity. It doesn't really matter where the parts of the graph are. In this case, I have a vertical asymptote. And again, I'm going to say that I have that vertical asymptote right there at A on my x-axis. All right, I'm going to call this graph h of x so I can talk about it. And I'm going to say that h of x has what we call an infinite discontinuity. at x equals a. So if you see a vertical asymptote, you're talking about what we call infinite discontinuity. All right, and our last type of discontinuity happens when we have a piecewise graph. It may have been a little while since we looked at a piecewise graph. But a piecewise graph is one that has kind of 2 or 3 different pieces. I'm going to do 2 pieces for right now. Maybe it looks a little something like that and like this. Okay, so some kind of piecewise graph. So obviously that one is discontinuous. It has a discontinuity because to draw this one, I would need to draw this piece, and then I'm going to say that I'm going to jump over to this other piece and draw it. So I do have to pick up my pencil to draw my graph. I'm going to call this one m of x so I can talk about it. And I used that word jump because when we have a piecewise graph like this, I'm going to call it a jump discontinuity at x equals a. Okay, so anytime you see a piecewise graph like that, this is what we call a jump discontinuity. Now be careful because they might ask you if something is continuous not at that place where x is equal to a. For example, they might ask you over here if my piecewise graph is continuous where x is equal to b. And at that point, my graph right there is continuous. Okay, so be really careful talking about these discontinuities. This one is only discontinuous where x is equal to a. So be very careful with those. Okay. All right, of our discontinuities, we have 2 different types. The first type is what we call removable, and the second type is what we call non-removable. All right, so let me write those down. We have removable, and we have non-removable. So there are 3 of these, and they split up between removable and non-removable. When we see point discontinuity, that is what we call a removable discontinuity. So if you see a hole in the graph, it's what we call removable. If you see infinite or jump discontinuity, that is what we call non-removable. Right? So if you see an asymptote or you see a piecewise graph, that is what we call a non-removable discontinuity. Okay, so all of those 4 graphs and the removable and non-removable are good vocabulary words that they'll kind of test you on. I'll show you in a few minutes. There's a good multiple choice question in a few minutes that kind of shows you how you get tested on these, so you'll be able to see those. All right. Hello. All right, let's get into some examples here. So I'm going to start with number 1a. If you remember, when we have a rational function where a factor cancels with a factor, we know that that's going to give us a hole in the graph. Okay, so think back to when we graphed rational functions, and if we have a factor that cancels with a factor, we're going to have a hole in the graph. So number 1 asks us to state the values of x where we have a discontinuity. So I'm going to say that this one has a point discontinuity in it. And that hole is going to happen at my x value that would make my denominator be equal to 0. So I'm going to say this one has point discontinuity at x equals -2. Because -2 would make my denominator be equal to 0. All right, any questions on that one? Okay, let's jump over here and look at a piecewise function. It may have been a little while since you worked a piecewise function, so let's take a look at that for just a minute. All right, with my piecewise function, I'm going to start with this x value right here. Even though one of them says equal to and one of them doesn't, I'm going to start with what's happening at that x value right there. Now the equal to is going to be a closed circle, and the not equal to is going to be an open circle. So I'm still going to find the y value that works with 1, but that's the difference, is that one gets a closed circle and one gets an open circle. Okay, so I'm going to start by plugging my 1 into my first function up there, and that's going to give me a y value of 4. So I'm going to take my 1 and plug in right here, and that gives me my first y value at a closed circle of 1, 4. Okay, then it tells me to continue that graph at x values that are greater than 1. So I'm going to go this way towards 2 and 3 and 4, and it's a parabola, so I'm going to make it just a little bit curvy. Since it's an x squared, I knew it was going to be a parabola. I don't need to be really specific with these graphs because I'm only looking for where the discontinuity is. Okay, so just a little sketch is fine. Okay, same thing on the second one down here. I'm going to take my 1 and plug in to my second function, and that's going to put me with an open circle at 1, -2. Okay, this one's just a line. When I look at 5x minus 7, I know that it's going to be a line, and again, I'm not really all that concerned with the slope of it or anything like that. I'm just trying to see the discontinuity. Okay, so it is most definitely a piecewise function. It most definitely has a discontinuity. Again, to remember this, I'm going to go along my graph. I'm going to take up my pencil and jump up here to the other piece. And so this one has jump discontinuity at that place where x is equal to 1. So good to kind of draw a picture of it and make sure that that's where the discontinuity is happening. Sometimes you'll need to draw a picture. Sometimes you can just kind of look at them and see that that's where the discontinuity is happening. Okay, any questions on part B? Okay, let's jump down to number 3. I'm going to skip over number 2 and go to number 3. On number 3 this time, we're trying to find the constant k. So here's k right here in my problem, that makes my graph be continuous. Okay, so rather than discontinuous, this time we want it to be continuous. Okay, let me show you kind of what it would look like if it was continuous. I'm going to still have my parabola up here. I'm going to still have my line over here, but I want for my open circle and my closed circle to touch. Okay, so that's what it's going to look like if I want it to be continuous, is I want my open circle and my closed circle to touch. Okay, in order to make that happen, I'm going to plug in the x value that they've given us. In this case, x is equal to 1. And then I'm going to set the two pieces that I have equal to each other. Okay, so when I plug in that x value of 1, I want my y values to come out to be equal so that my two pieces are touching. Okay, so in this case, I'm going to take my 1 and plug in for x on the one side, and then I'm going to set it equal to 1 plugged in for x on the other side. Okay, so they look a little intimidating, but they're really kind of easy. Just plug in that x value. And now the only variable I have left is k, and I can solve for k. And that's what they're asking me to do, is to find the k value. All right, so I'm going to say that 1 squared plus 3 gives me 4, equal to k minus 7. K times 1 is just k. And I'm going to add my 7 over to the other side, and that gives me 11. Okay, so every time you see a question like this, whatever the x value is, plug it in for x, and then set the two pieces equal to each other. Solve for k. All right, any questions on number 3? Okay, turn over to the back side, and I'm going to start with number 5, because number 5 is really the same question. It's just that the values they've given us are a lot harder to work with. So I want to give you some hints on this. I'm still looking for where f is continuous. Okay, I'm looking for where I have a continuous value for my function f. All right, I'm going to take my 1/2 this time and plug in. Now let me tell you, there's a typo on my worksheet here. And this one should be negative 50 over 3, which, hint, hint, becomes the answer. If you don't fix answer choice B, there's no answer on there. Okay, I'm going to do the same thing. I'm going to start by taking my 1/2 and plugging it in for x. What's tricky about this one is that we've got a lot of fractions to work with. All right, so I'm going to start by plugging 1/2 in for x in the first piece. Then I'm going to set it equal to 1/2 plugged in for x in the second piece. Okay, so the first thing you want to do is take the number they've given you, bless you, and plug in for all of the x values and set them equal to each other. Okay, let's do a little algebra. I'm going to cube my 1/2. When I cube that, I'm going to cube the top, and I'm going to cube the bottom. So that's going to give me 1/8 k. I'm going to keep my 1/2 k and my 1/4. I'm going to go through and get rid of all those fractions here in just a second. Okay, so hold on to that for just a minute. All right, over here, I'm going to jump over here on the side and do a little bit of work. The first thing I need to do is square 1/2. So 1/2 squared is 1/4. Square the top and square the bottom. All right, 1/4 of 32 is like 32 divided by 4, which gives me 8. And 8 minus 2 gives me 6. Okay, now an easy way to get rid of all the fractions so you can quit having to deal with those is to multiply through by a common denominator. Just make sure that you multiply on both sides by the common denominator. So my greatest common denominator here is going to be 8. All right, so I'm going to multiply through by 8. And what that's going to do is get rid of all of those fractions for me. So I'm going to do 8 times the 1/8. I'm going to do 8 times the 1/2. I'm going to do 8 times the 1/4. And then don't forget to do 8 times the 6 all the way over there on the other side. So watch out for that. That's probably the most common mistake that I see is people forgetting to multiply the 8 on the other side also. All right, so 8 times 1/8 just gives me 1. So that's just going to be k. So on that first multiplication, my 8's cancel out, and I'm just left with 1. All right, when I multiply 8 times 1/2, half of 8 gives me 4. And 8 times 1/4, so 1/4 of 8, or 8 divided by 4 gives me 2. And then again, don't forget to multiply over here. 8 times 6 gives me 48. Okay, watch out for multiplying on the other side. Don't forget to do that. All right, a little bit of simplifying. I'm going to say that 1k minus 4k gives me negative 3k. And I'm going to add my 2 over to the other side, which gives me 50. And then divide by that negative 3. Magically, it comes out to be answer choice B, which I had to fix. We had to fix answer choice B. I grabbed that one off of online, and the answer choices were not there. Okay, any questions on number 5? All right. Number 6 is a really good vocabulary question. Let me give you a few minutes to try number 6. So work together. See if you can figure out on your graph on number 6 where you have these different types of discontinuity. Okay, so see if you can try number 6. Work together in your group and try number 6. All right, if you're ready, you can check your answer on that one. Correct answer should be C. Let's kind of go through really quickly. So this one is asking which of the following statements is true. Watch out for that. Sometimes they'll ask you which one is false. So make sure that you know if they're asking true or false. So the first one is asking if x equals 1, that's going to be right here, if that has an infinite discontinuity. Infinite discontinuity is when you have an asymptote. So that one would be true. Did you jump over to 2?
Yeah,
I did that the first time I worked this one. I thought that this was the axis, and I jumped over here to 2. Yes, yeah, watch out for those. I know, and the numbers are a little bit hard to see on here. Yeah, so watch out for that. Good. Okay, on number 2, it asks me if we have removable discontinuity where x is equal to -1. So removable discontinuity is asking if it has a point discontinuity. I'm sorry, this one's asking about non-removable. Non-removable means that we're talking about an infinite or a jump discontinuity. Okay, so back over here at x equals -1, I'm right here. And right there, I do have a jump in my graph right there. So piecewise function comes here. I have to jump to the other piece and go over here. So this one does have a jump on it, which is non-removable. So that one is correct. Okay, and then my last one, ask about where x is equal to 2. X is equal to 2 is right here on this one, where I have a hole in my graph. A hole in my graph is a point discontinuity, which is removable. So this one right here is false. Again, we're looking for the answers that are true, and so my answer choice would be C. All right, any questions on number 6? Okay, let me give you a minute to try number 4. What you want to be careful with on number 4 is that it's asking you about it being continuous at x equals 1. It's asking you about it being continuous at x equals 1. So one of the choices does have a discontinuity, but it's not where x equals 1. So watch out for that. You're only checking for x equals 1. Like a piecewise situation because of the way they've written it, but a piecewise will have inequalities in it. It'll have the greater than and less than signs in it. So anytime you see that equal to and not equal to, you're looking at something with a hole in it. And that hole is happening right there at 1. So this one is discontinuous at 1. This question is asking us for which one is continuous. On the second one, I've got either a hole or a vertical asymptote happening where x is equal to -1. So this one is discontinuous at -1, but the question was asking me about +1. So it's discontinuous at -1, but it is continuous at +1. So we'll go ahead and say that yes, that one is true. That one is continuous where x is equal to 1. And then on choice number 3, we're looking at a piecewise function. So I took 1 and plugged it into both pieces. And what I'm looking for is, are they equal? So if they're equal to each other, that means that they touch. So I plugged in 1, and I found out that 2 did equal 2, so it is continuous at 1 on choice number 3. So my answer there is C, 2 and 3 only. All right, any questions on number 4? Very good. Okay, let's go through number 7 together for just a second. On number 7, this time we're looking for jump discontinuity at x equals 3. Okay, so I'm looking for a piecewise function where I don't have discontinuity at x equals 3. So again, we're looking specifically at x equals 3. All right, let me start by again saying that this notation right here is going to give us a whole or point discontinuity. Okay, so we already know that it's not going to be h because that notation right there tells me that that's a hole in the graph and not jump discontinuity. Okay, the other two could be jump discontinuity. The notation is okay on them. So what I'm going to do is I'm going to take my number 3 and I'm going to plug in to both pieces and see if they are equal to each other. Okay, so I'm going to plug into both the top piece and the bottom piece, and I'm going to see if they're equal to each other. All right, so this one gives me 9 minus 12 plus 1. I'm looking to see if that is equal to negative 2. So 9 minus 12 gives me negative 3, plus 1 does give me negative 2. And that is negative 2. So this one is continuous. Because they are equal to each other, this one is continuous. I'm looking for the one that has discontinuity. Okay, so I know that it's not going to be F. But I need to check G because none of these is also an option, so be careful with that. All right, so checking G, I'm going to have 3 squared plus 2 times 3, and I want to know if that is equal to 4 times 3. So I'm going to take my 3, plug into both the top and the bottom piece. If it is discontinuous, they will not be equal to each other. So I want to know, is 9 plus 6 equal to 12? And 9 plus 6 is not equal to 12. So there's my jump discontinuity. So on this one, G is my only correct answer, and that is answer choice B.